Hey guys, how you doing today? We're gonna go over L'Hopital's rule. So L'Hopital's rule is something that you're gonna be happy that you learn because it allows you to differentiate pretty much any function that has an indeterminate form for any specific limit. Okay, so if you get any number divided by 0, you can use L'Hopital's rule, and you don't have to factor. If you struggle with factoring, then this is really gonna help you. So let me show you. The rule, I'm going to give you the definition because it's pretty simple to understand. You just need to use some derivatives. So it basically goes like this. If you have the limit as x approaches any number a for a composite function, that is, you have two functions, okay, or two algebraic expressions. Remember, a function is just simply algebra, any algebraic expression. If you have this form, okay, so assuming that g of x somehow goes to 0, what you can do is you can find the derivative of f and the derivative of g. And you can find this limit. You can now plug in a for these functions, and that's it. That is your limit. Now, something I want you to be, I need you to be careful of is that you cannot use L'Hopital's rule if you do not have an indeterminate form. So if you can just simply substitute and find the limit, L'Hopital's rule will not work. So let's show that. So if we have the limit as x approaches 2 for the function 4x squared over let's say 3x, okay, you could even just divide that and see what you get, but in this case there is no indeterminate form. You're just gonna get 16 over 6, and this is just simply gonna be 8 over 3. Now if we used L'Hopital's rule in this case, we're not gonna get this value. We should get we could say this entire thing, I'm gonna use a parenthesis, should be actually, well, we know it's not gonna be, but just so you see like the relationship, we could say it's gonna be the limit x approaches to 4. Now the derivative of this, we can just use the power rule. We know that it's just going to be 8x over 3. Okay, this is going to be the derivative of this is gonna go to 1. And now if we plug in 2 into this expression, we're just simply gonna get 16 over 3. Okay, which is totally different from what we have up here, okay? You might see some resemblance between, well, 16 over 3 and 8 over 3. It's like if you multiply this expression by 2. But in this case, that was just like some coincidence, okay? When you use L'Hopital's rule in cases that you cannot use it, you're not gonna see pretty much any resemblance, or maybe just a bit, but maybe not this much between the two values or the two results that you get, okay? So let's do this example. Now in this case, we know that if we plug in 3 into the denominator, we are going to get a denominator of 0, okay? So we cannot do that. Now we're going to use L'Hopital's rule and see what it happens. So basically, we're going to differentiate top and bottom. So we're going to have the derivative with respect to t for the function t squared minus 4t plus 3. This entire thing also divided. The derivative with respect to x for t squared minus 3t, and this is gonna be 2t minus 4, okay? In this case, t goes to 1 and 3 goes to 0, over, we have 2t minus 3, okay? And now what can we do in this case? Well, we can actually, now we can plug in 3, so we're not gonna get a denominator of 0, so we're just gonna say this is, I'm gonna take an arrow and continue on here. So we're going to say this is the limit as t approaches 3 for the function 2t minus 4 over 2t minus 3. And now you can just simply plug in 3. So you're going to have 6 minus 4 over 6 minus 3. And this is just going to be 2 over 3. And this is the limit for this function right there. And we did it using L'Hopital's rule, okay? Now let's try this example. We have cosine of h plus sine of h over h minus 1. We've got our composite function. We got one in the top and one in the bottom. And we've also got a limit that is going to yield an indeterminate form, okay? Now what are we going to do? We're going to use L'Hopital's rule. So we're going to take the derivative on top with respect to h for the function cosine of h plus sine of h. And we're going to divide everything by the derivative of the bottom. And now let's see how much we get. So from this, we're going to have the derivative of cosine of h. We know it's going to be sine, negative sine of h plus the derivative of sine of h, which is going to be cosine of h. And all of this over, this is just going to be 1, okay? The constant goes to 0 and the h just goes to 1. So now we can write this as the limit as h approaches 1 for negative sine of h plus cosine of h. And now we can plug in 1 into this. So we're going to have a negative sine of 1 plus cosine of 1. Now, how much is this? Approximately sine of 1 is like, give or take, like 0.8. I think it's 0.8. Those are like the inputs you usually take to see how much you get. I think it's 0.8. We're going to say 0.8. So we're going to have negative approximately 0.8. You can confirm it with a calculator, but I think it's 0.9, 0.8, I think. Yeah, 0.8 plus cosine of 1. I think cosine of 1 is 1/2. Plus, I think, yeah, it's 1/2. Or at least approximately. So that would be 0.5. So we would just simply get negative 0.3, which is just, yeah, negative 0.3. So this is how much we get for this limit right there, okay? Approximately, very approximately. That is how much we get. So basically, we use L'Hopital's rule to do something that we wouldn't normally be able to do with factoring rules, okay? And I think this is very powerful, okay? I'm pretty sure you see how powerful this is. For pretty much any function that gives you something that doesn't exist, well, you can do L'Hopital's, okay? So I hope you guys enjoyed this video and see you in the following one.